Hello, I'm teacher Masika Michael. I'm a teacher of chemistry, and I would like to take you about the topic of the mole. The subtopic is empirical formula. But before I do so, please subscribe to my YouTube channel and turn on the notification button so that when I upload another video, you can get the content that I post. So, straight to the point, what is empirical formula? What is the empirical formula? This is the simplest whole number ratio of elements present in a compound. Most interestingly, I would like to take you to some of the problems that I'd like us to go through involving empirical formula. And the first one is calculate the empirical formula of a compound that contains 10 grams of hydrogen and 80 grams of oxygen. When you get a problem like this one, because looking at the question, it has two elements, hydrogen and oxygen. So you come down here and you draw a table starting with element. And we have two elements here. The first one is hydrogen. So you put here H for hydrogen. The second element is oxygen. So you put here O for oxygen. And you complete that table like that, like this. So looking at these elements, the first element, hydrogen, the mass has been given and the mass is 10. So the mass for hydrogen is 10 grams. Then the mass for oxygen given is 80 grams. We have also been given the relative atomic masses. For hydrogen, we have been given the relative atomic mass. The relative atomic mass for hydrogen is 1. For oxygen, we have been given 16. So we calculate the moles of each of the substances. And the moles is equals to mass that we have been given, divided by the relative atomic mass. For hydrogen, the mass is 10. So to get the moles of hydrogen is 10 divided by 1 equals to 10. Oxygen, moles equals to mass, which is 80 divided by 16. 80 divided by 16, you get 5. Then we calculate the simplest mole ratio. SMR stands for simplest mole ratio. To get the simplest mole ratio, we divide the moles of each substance by the smaller value, and the smaller value is 5. So for hydrogen, it's going to be 10 over 5, which gives us equals to 2. Oxygen is 5 divided by 5 equals to 1. So the empirical formula is going to be hydrogen. Hydrogen is H is 2. So it's going to be H2 because hydrogen is 2. Then oxygen is 1. So because it's 1, it's not a mass that we write that 1 here. So the empirical formula is H2O. Question 3. Question 3 reads, determine the empirical formula of a compound that contains 85.7% carbon and 14.3% hydrogen. Carbon equals to 12, hydrogen equals to 1. So again, we come up with a table again like this. So we write here element. So we have two elements. This compound contains two elements. The first one is carbon. The second one is hydrogen. Percentage composition. Percentage composition, we have two elements. The percentage composition of carbon we have been given is 85.7. And the percentage composition of hydrogen is 14.3. Then, remember the total percentage composition for the two elements should be 100%. So the relative atomic mass for carbon is 12, hydrogen is 1. Moles, we can calculate moles in another way by saying moles equals to percentage composition divided by the relative atomic mass or molar mass. The percentage composition of carbon is 85.7 divided by 12, and that gives you 7.142. for moles of hydrogen equals to percentage composition of hydrogen, which is 14.3 divided by the relative atomic mass, which is 1, equals to 14.3. Then we calculate the simplest mole ratio. We have said the simplest mole ratio, we look at the two moles that we have gotten, then we divide each by the smallest value. And among the two, between 7.142 and 14.3, 7.142 is the smaller one. So we take 7.142 divided by 7.142 equals to 1. Then for hydrogen is going to be 14.3 divided by 7.142 equals to 2.002. You see, 1 for carbon is a whole number, but for hydrogen is not a whole number. The simplest mole ratio should be a whole number. So we get the simplest whole number ratio. So for carbon is going to be 1, and for hydrogen is going to be, we round off to the nearest whole number and it becomes 2. So based on this, the empirical formula for this compound is therefore going to be C. For carbon is 1, so it is just C. When it's 1, we don't write that 1, so it is C. Then hydrogen, there are 2, so it is CH2. That is going to be the empirical formula of this particular compound. Let me take you through another question. Question 4. Question 4 reads, a compound was found to contain 40% carbon, 6.67% hydrogen, while the rest is oxygen. Determine its empirical formula. So again, we start with element. And this compound has 3 elements. The first one is carbon. So the first one is carbon. Number 2, the second element is hydrogen. And the rest is oxygen. So the third element is oxygen. So the percentage composition of each element, starting with carbon, we have been given the percentage composition of carbon is 40%. Then hydrogen, the percentage is 6.67. Then for oxygen, remember the total percentage composition for carbon, hydrogen, and oxygen is supposed to be 100%. So to get the percentage of oxygen is going to be 100 minus 40 plus 6.67, so that you get 53.3%. Then the relative atomic mass for carbon is 12, hydrogen is 1, oxygen is 16. Moles of each substance is given by percentage composition over the relative atomic mass. Then the percentage composition of carbon is 40, so it's going to, the moles of carbon are going to be given by 40 divided by 12. And 40 divided by 12 gives 3.333. Then for hydrogen is going to be percentage composition of 6.67 divided by 1 equals to 6.67. Then for oxygen is going to be percentage composition, which is 53.3 divided by the RM, which is 16. So that for this one we get 3.33 again. Then we get the simplest mole ratio. The simplest mole ratio, we divide each by the smaller number of moles. So we are going to take we are going to take 3.333 divided by 3.333, so that we get 1. For hydrogen is going to be 6.67 divided by 3.333 equals to, here we are going to get 2. For oxygen is going to be 3.33 divided by 3.333. We get 1. So the empirical formula is going to be, for carbon we can see that there is one carbon atom. We have gotten one here. So carbon is 1, hydrogen is 2, then oxygen is 1. So that becomes the empirical formula. Let me take you through a slightly different problem, because this one is involving elements and compounds. That is question 5. A hydrated salt has the following composition by mass. Iron is 20.2%, oxygen 23%, sulfur 11.5%, water 45.3%. Determine the formula of the hydrated salt. So this salt, we are going to begin by writing here the substance. This substance, we are using the word substance because this time round this substance could either be element or compound. So the first one is iron, and therefore we draw our table here. The first one is iron. Iron is Fe, and the second one is oxygen. The third one is sulfur. So we are going we are not going to make oxygen the second one. We shall put sulfur here first, then oxygen will follow, then water will be the last one. Then we have the percentage composition of each substance. The percentage composition of iron given is 20.2. For oxygen, it is 23. For sulfur, it is 11.5. Then for water, it is 45.3. Then the relative or the molar mass of each substance. For iron, it is given here, it is 56. Sulfur given is 32. Oxygen is 16. And water is, remember hydrogen, the molar mass of hydrogen is 1. So to get the molar mass of water is going to be given by, water is 1 times 2, because each hydrogen atom has a molar mass of 1 and there are 2, so it's 1 times 2 plus oxygen is 16, that comes to 18. Now we get the moles. Moles is equals to percentage composition over molar mass. The percentage composition for iron is 20.2 divided by the molar mass of 56. That is going to give us 0.3607. Then sulfur is going to be 11.5 divided by 32 equals to 0.3594. Oxygen is going to be 23 divided by 16, and that gives 1.4375. Water is going to be 45.3 divided by 18, which gives us 2.517. Then we have gotten the moles of iron, moles of sulfur, moles of oxygen, and moles of water. Now we get the simplest mole ratio. We look at the moles of each substance and we divide each one by the smallest number of moles. Looking at the 4 moles that we have calculated, the smallest number of moles are the moles of sulfur. So we are going to calculate divide all the moles that we have calculated by the number of moles of sulfur. So beginning with iron, we are going to take 0.3607 divided by the moles of sulfur, which is 0.3594. So that when you do that calculation, you now get 1.0036 Those are the moles of iron. Then for sulfur is going to be 0.3594 divided by 0.3594, so that you get 1. Then for oxygen is 1.4375 divided by 0.5394, so that we get for oxygen we are going to get 3.9997. Then for water is going to be 2.5, these moles, 2.517 divided by 0.3594. So that now the answer that we get here is 7.003. Then finally, we get the simplest whole number ratio. The simplest whole number ratio. For the simplest whole number ratio is now going to be, because this 1.0036, rounding to the nearest whole number is 1, then for sulfur it is already a whole number, it is 1. Oxygen 3.9997, we round it to 4. Then water, which is 7.003, we round it to 7. And finally, now we have the ratios in which these elements or substances combine. So the formula of the compound is going to be Fe. Iron is 1, so Fe is 1. Then sulfur is 1, so it is just S. Oxygen is 4, so it's going to be O4. Then the water of crystallization is 7, so it is 7 water, so it's 7H2O. And finally, for today, the last problem is this. A weighed sample of crystalline sodium carbonate, Na2CO3, NH2O, was heated in a crucible until there was no further change in mass. The mass of the sample reduced by 14.5. Calculate the number of moles N of water of crystallization. So we want to find the value of N. So remember, when sodium carbonate is heated, from your basic knowledge on salts, sodium carbonate does not decompose on heating, but it only loses water of crystallization. So when sodium carbonate was heated, its mass reduced by 14.5%, which means the percentage of water which means it lost water of crystallization, and the percentage of water that was lost was 14.5. And what remained is therefore anhydrous sodium carbonate, which is the remaining percentage. So here we are going to deal with compounds. We are not dealing with elements. We have compounds, or we have compound. The first compound is sodium carbonate, and the second compound is, of course, water. So the percentage composition of water is 14.5%, because the mass of the solid reduced. This is percentage composition, The percentage composition of water is 14.5, because when this sodium carbonate was heated, the mass reduced by 14.5, which means water was lost. This reduction was due to loss of water of crystallization. So the percentage of water lost was 14.5. So let's get the percentage composition of sodium carbonate. The total percentage of sodium carbonate and water is supposed to be 100. So to get the percentage composition of sodium carbonate, we are going to take 100 minus 14.5, so that we get 85.5%. Then the molar mass. Let's start with the molar mass of sodium carbonate. Sodium carbonate has 2 atoms of sodium. Each has an RM of 23. So to get the molar mass of sodium carbonate is going to be 23 times 2. That is for the 2 atoms of sodium that are there, plus carbon is 12. So plus 12 plus oxygen. Each oxygen atom is 16. So it's going to be 16 times 3. So when you add the total, you get 106. That is the molar mass of sodium carbonate. And for water, the RM of one hydrogen atom is 1 and there are 2. So it's going to be 1 times 2 plus oxygen. Oxygen, the RM is 16. The total is 18. So we are going to calculate the moles of sodium carbonate and the moles of water. So moles of sodium carbonate are going to be given by the percentage composition of sodium carbonate, which is 85.5 divided by molar mass of sodium carbonate, which is 106. When you do that calculation, you get 0.067. Then for moles of water is equals to percentage composition of water, which is 14.5 divided by the molar mass of water, which is 18. And when you do that, you get 0.8056. Then now we get the simplest mole ratio. The simplest mole ratio, you're going to divide by the smaller number of moles. So which are the moles of water, which appear slightly smaller. So it's going to be 0.8067 over 0.8056, which actually you get 1. And for water, you get 0.8056 divided by 0.8056, and you also get 1. So which means the ratio in which sodium carbonate and water had combined is in the ratio of 1 to 1. So which means the value of, because the question is to get the value of n, so meaning n equals to 1. Thank you very much. In the next lesson, I'll give a presentation on molecular formula. Bye.